Tesla just killed the Model S and Model X to build a robot army. And the Generation 3 Optimus has abilities that most people don't even know exist yet. Section 1. The Pivot. In early 2026, Tesla discontinued the Model S and Model X, the vehicles that built the brand. The Fremont factory is being converted into a dedicated production hub for humanoid robots and cybercabs. Combined S and X deliveries had dropped to 30,000 units, just 3% of Tesla's output. The factory was running at 30% capacity, so Musk ripped the old lines out. Tesla's capital expenditure for 2026 exceeds $20 billion, double what they spent before. The Optimus supply chain is completely separate from the car business. New vendors, new tooling, built from scratch. The target at Fremont? 1 million robots per year, one factory, 1 million humanoid robots. Tesla is betting its entire valuation on physical AI, and the Gen 3 is where it starts. Section 2. The hands and body. So let's talk about what makes this thing genuinely terrifying. And it starts with the hands. The Generation 2 Optimus had 11 degrees of freedom in each hand, but the Generation 3? 22 degrees of freedom per hand, with 3 more in the wrist and forearm. That's 25 total per arm. 50 actuators across both upper limbs. A 4.5x increase in actuator density. The design is straight out of biology. Actuators packed into the forearm pulling tendons to move fingers, just like your own arm. This makes the hand lighter and faster. Each fingertip carries tactile sensors detecting pressure, shear force, and texture in real time. It can handle a delicate battery cell 1 second and use a screwdriver the next without recalibration. Position accuracy of 0.05 degrees, 20 times more precise than standard industrial robots. Response time of 3 milliseconds, faster than human reflexes. The Gen 3 weighs 57 kilograms, a 22% reduction from previous versions, without sacrificing strength. Aerospace-grade alloys and carbon fiber panels with tensile strength of 3,500 megapascals, 10 times stronger than steel, 80% lighter. Noise at idle? 25 decibels, quieter than a library. Under max load, 55, normal conversation volume. This thing works in your living room and you'd barely notice. Section 3. The brain. And if you think the hardware is impressive, wait until you hear what's running inside this thing's head. The brain runs on Tesla's full self-driving vision stack. 8 cameras, 360-degree view, no LiDAR. Pure vision processed by a bird's-eye view network, mapping environments in real-time 3D. The breakthrough is how it learns. Gen 3 uses vision language action models. The robot watches a video of a human doing a task and replicates it. Sorting parts, folding laundry. No scripting, no teleoperation. And every hour any Optimus operates anywhere improves every other unit in the fleet. Tesla calls this the flywheel effect. Backing this is the AI5 and AI6 chip families, 50 times more powerful than current hardware by 2027. Tesla is building a fab on the Giga Texas campus to design and test chips in-house. If you want to understand what's actually happening in AI and robotics, not the hype but the real engineering, subscribe. We break down every major move so you're never caught off guard. Section 4. Digital Optimists and Secret Abilities. But the physical robot is only half the story. In early 2026, details emerged about a joint Tesla and xAI project codenamed Digital Optimists, also known by its more provocative nickname, MacroHard. Yes, that's exactly the jab at Microsoft that you think it is. It's a dual process system designed to emulate entire software companies. System 1 is a fast executor processing real-time screen activity, mouse movements, keyboard inputs. System 2 is xAI's Grok language model, providing strategic reasoning and planning. Together, they operate software like humans do, clicking buttons, filling forms, navigating menus, without relying on brittle APIs. Musk says it could manage accounting, HR, and data entry for any business. The AI4 chip delivers inference at $650 per unit. Deployment target September 2026. Now here's where it gets genuinely wild. Musk shared a video of Optimus Gen 3 doing something no one expected. Kung Fu. Not pre-programmed sequences, not teleoperation, fully autonomous martial arts. The robot greeted a human instructor and then proceeded to flawlessly mirror complex blocks, stance shifts, and coordinated arm movements in real time. On the surface, that might sound like a gimmick, but here's why it matters. To perform Kung Fu, a bipedal robot has to maintain perfect dynamic balance while executing high-velocity multi-axis movements. That means the neural network is solving for balance, trajectory, force distribution, and timing, all simultaneously, all in real time. If it can do that, it can work in unpredictable factory environments. It can navigate cluttered homes. It can recover from stumbles and collisions. And it's not just martial arts. The Gen 3 has demonstrated egg cracking, real-time force feedback modulation, delicate enough to crack an eggshell without crushing the contents. It's held yoga poses that require sustained micro-adjustments across dozens of joints. Walking speed has hit 8 kilometers per hour, a 30% increase in locomotion efficiency over Gen 2. And it can autonomously charge itself by visually locating its charging station and plugging in using rear camera guidance. Musk has gone as far as saying this level of precision could eventually exceed the capabilities of the best human surgeons. A robot that can crack an egg performing surgery. That's not science fiction anymore. That's an engineering roadmap. Section 5. Competition. Now, Tesla isn't alone in this race, and the competitive landscape in 2026 is fierce. The 1X Neo from Norway is targeting the home market directly. $20,000 or $499 a month to lease. It weighs only 30 kilograms, the lightest full-size humanoid on the market. Instead of rigid joints, it uses tendon-driven actuators that yield on contact. If you bump into it, it gives way. That's critical for a robot designed to live in your home. It matches Tesla's 22 degrees of freedom per hand, and its Redwood VLA model was built with OpenAI. The Xpeng iron sits at about $150,000, with 82 total degrees of freedom. It's the first humanoid with an all-solid-state battery. 3 in-house Turing AI chips deliver thousands of TOPS of onboard computing, processing vision, speech, and movement all simultaneously, all locally. Then there's Figure 03 running BMW pilot programs with its Helix AI system, Boston Dynamics Atlas with 50 degrees of freedom, Unitree G1 shipping right now for $16,000, Agility's Digit working with Amazon in logistics. The industry consensus? Xpeng has the most impressive hardware. Figure 03 has the most credible autonomy demos. 1X Neo has the strongest consumer story. But Tesla's Optimus Gen 3 remains the most commercially ambitious project in the field, because nobody else is planning to build millions. Section 6. The TerraFab and manufacturing. All of this only matters if Tesla can actually build these things at scale, and this is where the TerraFab comes in. This is the real inflection point. The TerraFab is a massive new facility being built on the Giga Texas campus in Austin. Its purpose? Produce 10 million Optimus robots per year. That's over 27,000 robots per day. To put that in perspective, the entire global industrial robotics market currently produces about 500,000 units annually, across all manufacturers, combined. Tesla wants to do 20 times that from one campus. The investment? $5 to $10 billion. 5.2 million square feet of new building space. The facility is designed for Optimus 5.4, built on data from 1,200 Gen 3 units already deployed at Giga Texas. Tesla's unboxed manufacturing process targets 50% cost reduction. The long-term target is $20,000 per unit. At that price, a robot working 24/7 at $2 per hour operating cost becomes cheaper than human labor in virtually every industry. Section 7. The bigger picture. Now, zooming out, all of this fits into a much bigger picture, and this is the part that keeps me up at night. Musk calls Optimus an infinite money glitch. A robot at $2 per hour delivers 5 times human productivity with no breaks or benefits. His revenue estimate? $10 trillion. Then there's Neuralink entering high-volume production. 12 patients have the N1 chip, with 1,024 electrodes. Paralyzed individuals control computers with thought alone. The connection to Optimus? Musk envisions paralyzed people inhabiting robots telepathically, performing physical tasks through a body that isn't their own. And space. Optimus D3 chips are being hardened for radiation and extreme temperatures. The goal? Send robots as colonization vanguard to build infrastructure on the Moon and Mars before humans arrive. Here's where we are. Tesla is no longer a car company. It is a physical AI company that happens to still make cars. The Gen 3 Optimus has hands more precise than a surgeon's, a body lighter than most adults, a brain that learns by watching, and a digital twin that can replace entire software departments. The TerraFab is being built right now in Texas to produce 10 million of these things a year. The MacroHard project is targeting a September 2026 launch. Neuralink is entering high-volume production, and space-hardened versions are already on the roadmap. This isn't a prototype anymore. This isn't a concept video. Gen 3 robots are rolling off production lines in Fremont this summer. And once they start collecting real-world data at scale, the flywheel kicks in. Every robot makes every other robot smarter, every day. The question isn't whether humanoid robots will change the world. That's already happening. The question is whether we're ready for what comes next. And honestly, I don't think anyone has that answer yet. If this video opened your eyes to something new, share it with someone who needs to see it. And I'll see you in the next one.